This video is on internal resistance. Question 1. Define internal resistance r units. Internal resistance is resistance in sources of electrical power like batteries. It has units of ohms, just like big R. Question 2. Define the following variables for the equation EMF equals I times big R plus little r. Draw an image to describe this equation. So little e is the electromotive force through the battery, has units of volts. Little r is the internal resistance through the battery, has units of ohms. Big R is the resistance in the resistor, has units of big ohms, has units of ohms. And I is the current flowing through the circuit, has units of amperes. So using this loop rule, we know that the EMF through the battery minus I little r through the battery minus I big R through the resistor is equal to 0. So you could see if little r equals 0, like we have an ideal battery, then V equals IR. But that's only an ideal battery. Question 3, a dry cell has an EMF of 3.04 volts. Its terminal potential drops to 0 when a current of 50 amps passes through it. What is its internal resistance? So this is what we do. We just plug it into the equation. Question 4. A cell has an EMF of 145 volts. This means that its terminal voltage is 145 volts where no current passes through it. When the terminal potential is 120 volts, the current through the circuit is 25 amps. So what is the internal resistance of the cell? Let's use this equation, V equals E minus IR. We get little r equals 1 ohm. Part B, what would be the terminal potential when the current is 12 amps? We use the same equation, we get 133 volts. Question 5, a cell with internal resistance is connected to a 3 ohm resistor. Determine the internal resistance little r of the cell if the current going through it is 2 amps when its EMF is 12 volts. So E equals I times big R plus little r. Plug in what we know, we could solve for little r. Question 4. A battery with internal resistance is connected to a variable resistor. When the resistor has a resistance big R of 12 ohms, the current is 2 amps. When the resistor has a resistance of 6 ohms, the current is 3 amps. Determine the EMF and the internal resistance little r of the battery. So they gave us two conditions. They gave us the resistance and current of two situations. So we could use this equation twice. We're going to have two equations and two unknowns. And we could solve for little r. Then we could substitute back to solve for EMF. Question 7. While attached to a 2 ohm resistance, the terminal voltage of the battery is measured to be 5.20 volts. The open circuit voltage of the same battery is measured to be 6.70 volts. Part A, what is the internal resistance of the battery? First use the equation V equals IR, then substitute back into the equation V equals EMF minus IR. Part B, what will be the maximum current that can be delivered by the battery? We'll use the equation V equals IR. Question 8. A battery is known to have an EMF of 4.60 volts and an internal resistance of 2.20 ohms. What will be the terminal voltage of this battery while connected to a load of 7.8 ohms? So you could see what we did here. First we use the equation V equals IR to solve for I, then we use the equation V equals EMF minus IR and substituted to solve for V. Question 9, consider the circuit below. So we have 6 resistors and 1 battery. Part A, what is the total resistance of the circuit? So first let's simplify these 3 12 ohm resistors in parallel. So our total is 4 ohms. Then now all of the resistors are in series, we could add up all the resistances. Part B, what will be the total current flowing through the circuit? We use the equation V equals IR. Part C, what will be the current flowing through each 12 ohm resistor? Well, they're all going to have the same current flowing through them because they're all in parallel. Part D, what will be the voltage drop across each of the 12 ohm resistors? We'll use the equation V equals IR. Part E, what will be the terminal voltage of the battery? Use this equation. Part F will be the voltage drop across a 10 ohm resistor. Use the equation V equals IR. Question 10, a battery which has an EMF of 6 volts and an internal resistance of 0.5 ohms is connected to a load which has a resistance of 3.5 ohms. Part A, what will be the current flowing in the circuit? So you could see the image that I drew, little r is part of the battery. I just broke it up into 2. The current flowing through the circuit, we're going to use this equation V equals E minus IR. And you could see with substituting, I ended up getting 1.5 amps. Part B, what will be the voltage drop across the load? It's V equals IR, which is 5.25 volts. Part C, how much power is being supplied by the battery? P equals IV. Part D, how much power is being consumed by the load? P equals IV once again. Part E, how much power is being consumed by the internal resistance of the battery? We subtract part C from part D. Finally, part F, what is the efficiency? With what efficiency is power being delivered to the load in the circuit? It's pretty efficient, 87.6%.